everyone. Today we are going to explore one of the most mind-bending concepts in physics, wave-particle duality. The idea that light and matter can be both waves and particles at the same time. The lecture notes are taken from Feynman's last lecture series, Volume 3, Chapter 1. For centuries, humans understood the world through classical physics. We could predict the trajectory of a ball, measure mass, and use Newton's law to explain motion. Everything was deterministic like clockwork. If you knew the starting point, you could predict exactly what would happen. Then scientists studied light. Maxwell proved light was electromagnetic wave. Young's double slit experiment showed interference pattern. Everything pointed to one conclusion. Light is definitely a wave. Then came the photoelectric effect experiment. When light was shined on a metal, it ejects electron. Here's the weird part. Bright light doesn't give more energy, only higher frequency light does. Einstein solved this problem by proposing that light is made of particles called photons. This won him his Nobel Prize. So, what do we expect in a slit experiment? When it's a light, we get interference patterns. When it is a particle, we get just 2 points where the particles could land. The probability being 50% on where it could land. But when electrons were passed through double slit experiment, which is a particle, it created an interference pattern. But why? Is electron a wave or a particle or both? Yes, the answer is both. We fire individual electrons through two slits. Each electron hits the screen at single point like a particle. But over time, they build up an interference pattern which only waves can create. Somehow, each electron interferes with itself as if it went through both the slits simultaneously. So, isn't it bizarre that the electron behaves as both wave and a particle at the same time? It's detected as a single point but creates a wave pattern. Nature is showing that our classical categories don't apply at quantum level. This leads to Heisenberg's uncertainty principle. The more precisely you know the particle's position, the less you know about its momentum and vice versa. This isn't a measurement problem, it's fundamental to nature. Wave and particle properties are complementary aspects of reality. So, this isn't an abstract theory. Wave particle duality powers modern technology. Electron microscopes use wave nature of electrons to see incredibly small structures. Semiconductors in our phones rely on quantum tunneling. Quantum computers exploit superposition. Medical imaging uses these principles. And lately, no, quantum got its Nobel Prize too. So, light is both a wave and a particle. Matter is both particle and wave. Reality at quantum scale completely defies our everyday intuition, yet it's the foundation of all modern physics and technology. Quantum world isn't some abstract realm, it's the real world underlying everything we see. Thank you.